So this is AS Maths October 2020 paper 2. This is the last of the statistics questions. So this is question 5. Okay, Africa works in a call centre. She assumes calls are independent and knows from past experience that on each sales call that she makes, there is a probability of 1/6, 1/6 that it's successful. Africa makes 9 calls. Calculate the probability that at least 3 of these calls will be successful. Okay, Africa works at a call centre. So it's up to you what you want to name things. Usually we do X, but we could call this A for Africa. So A is the number of calls that she makes, successful calls, and this is going to belong to a binomial distribution where the number of calls N is 9 and the probability of success, the P, is 1/6. So that's 1 mark in the bag, and it's only 2 marks for this probability. So at this point then, calculate the probability that at least three. So because we want the probability of at least 3, it means A is greater than 3. Greater than or equal to 3. So I always write down 0 because everyone forgets that there is a thing called 0. And then I do the number before and after the probability we're looking for. So that's 2, 3, 4, ... 9. Potentially I'd write all the numbers out because it's only 9, and that's fine. So we want at least 3 calls. So do we want 3? Yes. Do we want 4? Yes. And we want everything above. So we want that. However, we can't do that unless we've got the really posh calculators. If we've got the class whiz, we can only find probabilities of less than or equal to. So less than or equal to 9, we know will give us a probability of 1. And then we want to take away that little bit. So that's 1. So if we rearrange it, we've got 1 minus, and that little bit, because it's less than or equal to, has to start at 2. Okay, so then we put 1 minus and work out what in your stats menu. I've got the posh one actually, let me swap to this one. So on menu, distribution. Yep, distribution. We want binomial CD, so it's cumulative. We're going to do variable 2. X is 2. The number is 9, and we're going to do 1 divided by 6 there. So I've got a probability of 0.82174004, and then I need to do 1 minus that, which hopefully I can do in my head. 1782595, approximately equal to 0.178 to 3 sig figs. Okay, next bit. So that's that one done. Calculate the probability. Okay, probability Africa makes a successful sales call is the same each day. Africa makes 9 sales calls on each of 5 different days. Calculate the probability that at least 3 of the sales calls will be successful on exactly one of the days. Now this starts to sound really confusing, but what you've got is, because you've got this at least 3 sales calls, and we did that with 9, everything's the same bar the fact that she's doing it repeatedly. So we can actually set this up as a new distribution. So I call it D for days. So it is still a binomial distribution. She's got 5 different days, and her probability of success is the probability of at least 3 sales calls. So it's 0.1782595 if we use it all. And the probability she wants exactly equal to 1 day, one of these days that this would happen. Calculate the probability of at least 3 sales calls will be successful on one of the 5 days. So this is an equal to, so you can either put it in your calculator like that, or you can do the formula, which is NCR, probability of success to R and probability of failure to N minus R. Or you can shove it in your calculator. So I'm going to go menu, distribution. I do 4 for binomial, PD, 0.2 for variable, and I'm going to stick in 1 and then 5 and then 0.1782595. and get my probability from that. And I've got 0.4064072588, which I can't fit in, which is 0.406 to 36. Good. Whew, that was a good one. So those can be off-putting. You can obviously set it up and write it out the way we did it, like this if you want to. Right, let's see what's happening now. So a bit of a change. So that's just two binomial probabilities. One's a little bit different, so that's fine. So this one now. Rowan works at the same call centre. Rowan, let's write his name down. The next 35, so it's binomial, next 35 calls, he thinks 11 of them are going to be successful. Okay, so we've got a H0 and a H1 because we're doing a binomial hypothesis test. Because binomial is all about probability, that goes there. H0 is always equal to, and we're saying that the original probability is 1/6, and he thinks he's better than, so he's going to get a better turnover. Because I've used the greater than sign, I'm going to say this is a one-tailed test, and they want a 5% significance level. Okay, so we're going to find out, so we want to know, with 35 things, what is, so this is, 35, 0. We want to know, well, we can do it two ways. We can find out where the 5% is, or we can find out whether 11, which is what he did, or greater than, the probability that R is greater than or equal to 11, because we need to add up all of these from 11 at wherever 11 is and see if it lies. So is the area probability, say if 11 was out here, and that would give us a probability of greater than 5%. If 11 was in here, greater than or equal to would give us a probability of less than 5%, so it would be in the rejection region, which means we would reject H0 and say he is a better salesman. So 0, like I did before, 10, 11, 12, ... 35. We want greater than or equal to that, so we're going to do 1 take away the 10. So that's equals 1 take away R is less than or equal to 10. Which is 1 minus, so go back to our probability, not the PD one, so you need to go back to distribution, page down, 1 for cumulative, 2 for variable, and I'm going to do 10 in there with 35, 1 divided by 6, so I've got 0.9768018, which if you do your 1 minus, you've got to add up. So that's going to be 0, 2, 3, 1, 9, 8, 1, or 2 to finish. So that is only 2.3%. So 11 is in here somewhere, and that area is only 2.3%. So we are in the rejection region, so we can say there is enough. Because this is this is significantly different up here, this bit. If you're in that 5%, don't think that's 95%. I know I haven't drawn it very like that, but if you think that's 95%, this is 5% probability to get up the 100% when we would add all those together. So it's extremely different from the norm kind of thing. And if you think about it, the mean is 35 times 1/6. Oh. Oh. My calculator's stuck. So that gives us 5.8 is an 11's quite a bit higher, isn't it? When you're talking about sales. So there is enough significant evidence. And then look back at your question, whether or not there is evidence to support. So we're just to support Rowan's belief. So we are rejecting H0 as Rowan has a bigger probability of success. Okay, than Africa if you want to say, but that's fine, okay. But Rowan has definitely got to be in there somewhere. Good, that's that binomial distribution, or binomial